Hello and welcome to the Emerging Technology Horizons podcast. I'm Arun, Deputy Director of the Emerging Technologies Institute. Today's podcast is going to focus on software, but we're not going to be talking about cybersecurity or artificial intelligence. We're going to be talking about the software defense industrial base, its productivity, and what we need to do to make sure that it meets DOD's future needs. My guest today is Dr. David Tate, Senior Analyst in the Cost Analysis Research Division of the Institute for Defense Analysis. David recently wrote a report called Defense Software Productivity Trends and Issues, and we're going to go dive into that a little bit here on the podcast today. Bio for Dr. Tate. David Tate joined the research staff at the Institute for Defense Analysis in the year 2000. In his 20 plus years with IDA, Dr. Tate has led acquisition cost, schedule, and risk reviews of multiple high-profile national security programs and has contributed to numerous Pentagon and congressionally mandated program reviews across multiple agencies, DOD, DHS, Department of Energy. He has authored or co-authored dozens of technical reports in the areas of decision analysis, portfolio selection, acquisition of autonomous systems, cost and schedule risk analysis, and acquisition of software-intensive systems. He's provided analytical support to multiple congressionally mandated studies and panels and has served on GAO's expert panels as well. Prior to coming to IDA, Dr. Tate was Senior Operations Research Analyst for Telecommunications at Decision Science Applications Incorporated. Before that, he was an Assistant Professor of Industrial Engineering at the University of Pittsburgh. Dr. Tate holds bachelor's degrees in philosophy and mathematical sciences from Johns Hopkins University, and a master's degree and PhD in operations research from Cornell University. Please join me in welcoming Dr. Tate to today's podcast. David, thanks for joining us today. Let me just start off by turning it over to you. Tell us a little bit about the report and what you found.
Thanks, Arun. Pleasure to be here. Basically, I got concerned a few years ago. I had read a 2006 report from CSIS about the demand and supply for software for defense purposes. And they had predicted that by 2012, 2013, there was going to be a crunch, that the supply would not be able to keep up with the demand. And so I started looking to see what had happened since then. And I discovered that apparently no one had checked, right? No one was tracking this. No one was even attempting to answer the question. So cobbling together the data sources I could find about growth rates for demand of software, size of the industrial base, productivity of the industrial base, I tried to predict as best I could where we stand now. And what I found was that if my numbers were right, we're already in trouble. This was a few years ago, that the amount of software we're asking for is growing significantly faster than our ability to produce it. And the size of the workforce we have currently, especially the cleared workforce, is not adequate even for what we're trying to do today. That sounded like a really bad thing. I don't want to be the guy who says the sky is falling, but I'm afraid that the sky is falling. And I would love to get external confirmation or people telling me I'm an idiot and here's why. So I put the paper out there, and I'm still waiting to hear back from someone who can tell me yes or no.
So software is, of course, used in every defense platform, weapon system, network, business system that DOD uses. But I don't think senior leaders in Washington think about software as something that's even to be considered as part of the defense manufacturing base. There's a lot of discussion about the health of the manufacturing base and all of the things we need to do to shore up the traditional defense manufacturing base. How would you approach making senior leaders think about defense software as a manufacturing issue?
That's a great point. I mean, not to pick on your organization, but NDIA puts out an annual State of the Industrial Base report. And this last year's report mentioned software exactly once in 70-some pages of discussion. And it said, prime contractors are having a hard time getting the talent they need. And that was it. That was the whole discussion. So I think it's not hard to explain to people why a shortage of welders at the shipyards would be a problem and why it would prevent us from doing the things we want to do with our shipbuilding program. I think there has always been an impression that the supply of software developers is essentially infinite, that it's an easy field to get into. It's an easy thing for people to learn. You don't even need a formal degree. Our software commercial base is thriving. So surely it must be producing all the people we need to do this defense software stuff. But there are reasons why that doesn't happen. I mean, the first one is that the commercial world is competing directly with the defense industrial base for what those people are going to be doing. And if they're, writing web commerce portals or designing generative AIs that do chatbots, then they're not building satellite systems or fighter avionics or the other things the DoD needs. The second is that we require that our contractors use cleared labor, people with security clearances. And most of the software industrial base does not have U.S. security clearances and could not get them. And getting a security clearance takes a long time. So there's a long lead time to start an effort and then staff it up with people who don't already have clearances. So that's a problem.
Did you look at the production of software engineers as opposed to, so you mentioned a couple of things which were about DOD's ability and defense industry's ability to acquire that talent. Are we producing enough talent?
So I looked at the educational pipeline and also the outputs of things like boot camp programs. And it looks like the overall U.S. Software base, right, commercial and government, has been growing at about 5% per year for a while on average, which is pretty good growth for a labor force, except when you compare it against the 15 to 25% annual growth that we see in demand for software. So that organic growth in the industry is not going to be enough to keep us from running out of talent. The international growth is better, but of course, international talent is harder to use in defense software. And so one of the things I talk about in my paper is whether much wider adoption of open source software in defense applications isn't something we need to do, because that gives us virtual access to the global software developer productivity in ways that we don't get if we require U.S. cleared labor to produce the code we're using.
So when you think about the demand side of this, then from DoD, leaving the workforce piece to the side for a moment, is there any way to measure the demand that DoD is going to have over the next X years for something called software? How do you even sort of wrap your head around that to know you have a shortfall?
It's a terrible problem. Measuring the output of software development is something that people have struggled with for a long time. Even in hindsight, looking back at the software we developed to say, well, how much did we get, is a really hard problem. There are some very bad metrics that people have used. Software lines of code, source lines of code, or SLOC, as they call it, was an attempt to measure how much software we got. But of course,
and that's basically what it says: the lines of code in a program. Basically,
literally, you write them down and count them. And anyone who's ever written software knows that how much work you can do with 10 lines of code is radically different depending on what language you're using and what kind of application you're doing. And also that how hard it is to write those 10 lines of code is radically different depending on the purpose of the software and how safety critical it might be. NASA did studies back in the day where for manned spaceflight applications, the most highly safety critical thing you can do, the productivity of the software developers was basically one line of code per developer per day over the course of the project, right? Which sounds insanely low. Right? If you're building web portals, you can do thousands of lines of code per developer per day for that kind of thing, because the risk of harming someone is much lower, and there are much better automated tools to support the applications. The big improvement over lines of code was the invention of what were called function points, right? Which is to say, well, let's not count, how we tell the software to do it. Let's say, what does it actually do? Right. So you list all of the functions that are accomplished. Here's a data retrieval. There's a calculation. Over there is writing something to a file. These are all distinguishable steps that software would need to do. And if you can sit down and write down what are all the things you require the software to do, that should give you an idea of how hard it will be to write. And especially for people who wanted to predict cost and schedule for software projects, this was a big improvement. Couple of problems with it. One is that the Defense Department asks software to do things that are not part of the standard list of functions that software should do. I mean, there's no International Function Point User Group category for cyber secure real-time tactical fighter avionics activities. And the other problem is that you have to be intimately familiar with the design of the software to be built in order to do this kind of analysis. So, for example, you could not do an independent cost estimate for the software that's going to be written for the F-35 or for the Global Positioning Satellite Ground System because outside the program, you don't have access to the details that would let you say what are all the functions that need to be implemented. So it's very much an insider thing that you can only do once and up close.
I guess the other thing that, people have started to come to is more stop thinking about lines of code or functions. Time is the most important factor in how quickly can you deliver usable software to a weapon system. Do you agree with that? Is that somehow going to factor into this discussion of productivity?
So I wrote a different paper about that last year. I am very much an advocate of Agile development. I think that it's a fantastic step forward in how we do manage software requirements. But the truth about Agile is that all of the benefits come, or the majority of the benefits come, from the work that you would have done but don't, because you discover in the process of doing the project that wasn't all that important anyway, right? And so it's the optional things that are never implemented that save you a lot of time, get things to the field faster, make it cheaper, make it more responsive to user requirements. What it doesn't change is the minimum implementation that is necessary in order to do the job at all, right? And in the commercial world, that minimum implementation can be almost nothing, and you can get it out the door quickly, and you can be agile almost from day one. If you're building a ground control system for the Global Positioning Satellite constellation, then it has to be able to manage a global positioning satellite constellation and all of the things that go with that in a secure manner, networked globally. The amount of work to implement the bare minimum you could live with is already years of development, right? It looks a lot like the old waterfall development process just to get to the thing that is the least you could possibly do. After that, if you've designed it well, if you've got the right architecture, you can go agile. But you're not saving any time or money in those first few years. And the labor force required to do that highly specialized work is not any easier to get just because you're planning to be agile someday.
Is it actually a bigger burden in terms of workforce to set up that, let's call it a pipeline for that first delivery of a defense minimally viable product, to set up that virtuous cycle of delivering every X months or every X weeks? Is it arguably more work up front?
I would argue that to do it right, if you really want to be able to make continuous improvements over a long time horizon, then you need more upfront architecture and design work. You need, more attention to modularity, more attention to open systems. And yes, that makes it actually a little harder upfront. and probably a little slower and more expensive to get that first increment if you're really going to make it something that you can build on in the future. There was a great paper a few years ago by Prashant Patel and Mike Fisher-Keller called Prepare to be Wrong, which argued that the most important thing to do with these long-lived defense platforms was to over-design them up front for future compatibility. Since we don't know what we're going to need, we need them to be able to support lots of different things potentially. And that kind of over-design gives you less capability in the first increment and takes longer to develop, which nobody wants to do.
And it's an argument that's not just being made in the software community, but also in the energy and fuel community and the microelectronics community. The over-design and the open systems up front saves you in the long term.
In the long term, there's a competition between hardware and software. And Moore's law says that the hardware is getting better faster than the software is. And so anytime you think you're going to put out a system that has stable hardware with changing software, you're in effect saying that Moore's law doesn't apply to my system, or that the time horizon is short enough that it doesn't matter, right? I worked years ago on the Joint Tactical Radio System, where the concept was that we would have portable waveform software that could be moved from one radio to another. We would buy a lot of radios once, and then we would be able to upgrade the software on them over time to do new radio functions. That didn't work. And part of why it didn't work is that the capabilities of the radios were getting better so much faster than the capabilities of the software that it was worth it to scrap all of the radios and buy new ones in order to get those upgraded features, rather than writing new software, which turned out to be slow and difficult anyway. So, an alternative approach would have been to say, let's go for modular hardware, where, think like the graphics cards on your computer, right? That as a new technology comes along, I can plug in a new graphics card and get much better capability without having to change the motherboard or the programming. That kind of approach to the hardware features of the radio would have been a totally different approach and might have worked better, but it's not what we did.
So in thinking about then this need and then the difficulty in us adjusting our acquisition practices the way you're talking about to do this, we'll argue more correctly, are there ways to just improve the productivity of the software manufacturing process, right? So Emerging Technologies Institute, we think about science and technology. There are a lot of DoD investments on improving manufacturing processes. Are people investing as well in improving software productivity processes?
We used to do that. Back in the 60s and 70s, DOD was probably the number one driver of software engineering innovation and research and development. Things like computer-assisted software engineering tools came out of DoD-funded projects. We don't do that much anymore. There's a belief out there that the commercial world has this covered, and that they are so much better than the defense world at software and at software development that we can be followers and not leaders, and that there's nothing there that needs to be funded. I think we're kind of stuck, that we've reached a point where without a order of magnitude improvement in the productivity of individual developers, we are never going to be able to keep up with what we're already trying to do. Now, the big change is going to be when software goes from being, well, for a long time it was bespoke manufacturing, right? Every piece of software was handcrafted by individual experts. We've gotten to a point where it is a lot more assembly oriented, that people are putting together existing software modules that exist in libraries and combining them in new ways to make new capabilities. That's a big help for productivity. Higher order languages are a big help and have been a big piece of improvement in productivity over time. But all that told, 4% a year is about what I estimate as the improvement in capability per developer per year improvement over time. What we need is to move to industrialization of software, automation of software production, where software can be mass produced. And I'm very interested to see all the discussion these days of large language models and generative AI, where people are saying, well, you can ask our large language model to write code that does XYZ, and it'll get close. And then the expert only has to tweak it a little bit, and we can move on. It would take something like that to get us back to being able to keep up with the growing demand. So I think that DOD should invest heavily in how to do assured, verified software that is at least initially generated by automation.
Software is a place in particular where DOD's struggling, partially because of the huge presence of commercial software industry and its huge investments, its capture of talent, its ability to push out products so quickly, but all slightly outside what DOD really needs, given some of the issues that you've raised here. So where do you see a place for DOD and the commercial sector to work better together to address some of the issues you're talking about?
It's a difficult question. DOD currently operates on timelines that are unacceptable to the commercial world. It takes too long to get things started and too long to start making money. There are too many alternatives that the commercial world has to do something else. DOD, unfortunately, does not get to choose which applications it wishes to develop. It has requirements based on mission needs. And the JROC doesn't care about the software industrial base. They say we need to be able to do this set of missions on these timelines effectively, or we can't do our job. So I think, frankly, there's going to have to be some, I mentioned shipyards earlier. There is a de facto public utility that builds ships for the United States, nuclear ships in particular, and we maintain it at great expense in order to have the capability to do that. For defense-specific software needs, I worry that we need to do something very similar, that we need to have the equivalent of public-specific shipyards, but for software, for the types of software that only DoD demands, which is mostly going to be high assurance, high security, real-time applications, space applications, command and control applications.
And you have to somehow do that in a way that doesn't then distance yourself from the market pressures that drive cost control, innovation, those sorts of things.
Which is the flip side of the shipyard problem. Yes, that's exactly right. It's a very difficult challenge, and I do think that it starts with the R&D. I think that to fund fundamental research into the pieces of the software productivity puzzle that the commercial world is not providing, which mostly is in high assurance kinds of areas, that you could create a corner of the industry that specializes in those applications and could have competition and could have innovation internal to itself without the government funding. But you have to recognize that it's a problem that the existing commercial activities are not going to solve.
So in terms of changing the behavior of DoD as a buyer of software, right? So you talked a little bit about the productivity side and R&D on that front, and then the workforce piece. But if you could change DoD's behavior as a customer, basically I'm saying acquisition reform, given your previous work in acquisition reform, are there certain policy recommendations that you would have or options that you would lay out for the department to think about in terms of behaving as a more intelligent software customer?
I don't see any silver bullets, but there are a few things that I think would help. Um, uh, Congress has asked for, and DOD has given lip service to modular open systems for a long time now, but it isn't really happening, right? No one is writing requirements that say that being modular and future compatible is every bit as important as, how fast it goes or how accurately it shoots or any of the other immediate performance requirements. Similarly, I think that leveraging open source software on a much larger scale, I mean, there have always been security concerns about open source, but frankly, there are ways in which open source software is more secure than custom software. It's had many more eyeballs on it and gets scrutiny in directions that other software does not. It's a different challenge, right? It's not insuperable, but it would radically expand the productivity of the DoD available workforce, and at least temporarily allow us to catch up and do other things. I don't see much promise in the idea of asking for less software. I mean, in theory, DoD could be much more strategic about which functions it implements in software and which functions it implements in hardware, and reserve the software for the ones that can only be done that way. There's no reason for the thermostat to be smart. A stupid analog thermostat will probably do for most applications. But again, there's almost no way defense-wide to coordinate rationing of capabilities like that, right? We have a hard enough time doing that with rare earth metals and batteries. It would be really hard to do it with software capability. So this is why the sky is falling. I mean, I don't, in fact, see any easy answers that get us to a resolution of the problem. I mean, we can delay catastrophe for a while, but I think until we get the ability to produce software, at least in order of magnitude, more efficiently than we currently do, we're not going to actually get ahead of the problem.
We're running out of time here, so I'm just going to close with one last question. Do you see any positive signs in the commercial world where they're taking on this problem, because they must see similar challenges, as well as even greater need for cost control and speed? Are they making the steps that you're talking about to improve their productivity of software?
Unfortunately, the signs that I see actually point the other direction. Something I've been watching very closely for a while is commercial activities in the area of self-driving cars, because that is the one application area, the one domain where the commercial world is trying to do something that is very safety critical and very complicated, right? And so how they went about that and what kinds of self-imposed restrictions they made, how they modeled assurance, how they dealt with insurance companies, all of those things have been very interesting to me. And what I find is that for the most part, the 100 companies that were trying to do this originally, most of them have dropped out and have said, no, there's just no profit there. It's too hard. We don't see any significant return that would be enough to justify spending all of our efforts when we could do something else instead. So there's still a handful of companies that are trying to make it happen, but it's one of those areas where the commercial successes in that area would have been directly applicable to defense systems, real dual use AI stuff, and that would have been fantastic, but it didn't happen.
So with that positive message, we'll call it. Thanks very much for joining us today, Dr. Tate. You pointed out a lot of areas for NDI members to think about, maybe something for IDA and ETI to work on together going forward. With that, I'm going to close. Thank you, Dr. Tate, for joining us today, and thanks everyone for joining us on Emerging Tech Horizons.
My pleasure.